Welcome grade 10s. We're here again on a beautiful Wednesday and we're doing life sciences. You're here with me, Megs, and of course my lovely leading lady, Cheryl. How are you?
So nice to have you back again.
So
No,
great.
I'm fine, but I was just talking to John now.
Mm-hmm.
The different you look with
My
the
hair
bangs.
is like
Yeah,
brown.
between you and Looney, you change your hairstyle queens all the time.
I know,
yeah.
John says,
Yeah.
do you have someone do your hair? I'm like, no. But thank you. This show is proudly sponsored by MTN SA Foundation and endorsed by the Department of Basic Education.
We're gonna start.
Yes, we're going to start. But
Get right
first, I need to tell them where we are and how everything operates. You know, just
Come here.
can't go into
You
things.
should be used to this. Go back.
So you find us, you find myself and Cheryl on facebook.com/LearnExtra, on Twitter @LearnExtra. Posted all the notes, all you need to know on the page already. Get going, get commenting, anything. I'm going to post pictures and then you can just comment on them, ask me questions, ask Cheryl questions. Also enter the Curio Challenge question, right?
Yes, there
We have
are
one of
10
those
of them.
again.
Yeah,
10.
there's 10.
Oh,
10
wow.
questions. Yeah.
And all you have to do is register for a free account and the passcode is LEARN. So please go get doing that. And we want to get some free airtime, guys. How awesome would that be? So that's all I have to say for now. I will leave my other little competition for after the break. So Cheryl, get it away.
Welcome, grade 10s. Those of you who live in Gauteng, lovely, lovely rainy weather,
Ooh,
ideal
terrible.
for studying.
No,
No.
sleep.
I think it's only teachers who think like that. I'm thinking, oh, awesome study
They
weather.
can't
The
go
kids are
out
like,
and play
no,
and
yeah, movies, duvet, TV.
Mm.
We are going to be looking at paper 2. Remember last week we looked at all the different sections that were in paper 1. Right, in paper 2 we are going to do, and I list them and then I'm going to go through the questions with them. Support system in animals, which is the skeleton. Remember in paper 1 is support system for plants. Do not get confused. Then we looked at transport system in animals, which is the circulatory system, the heart, the lymphatic system. In paper 1 we looked at the transport system of the plants. So the plants are in paper 1, the animals are in paper 2. And then so we've got the skeleton, right, the support system, transport, the cardiovascular system, then we've got the environmental, that's all the food chains, all the biosphere, lithosphere, herbivore, carnivore, omnivore, all of those. Then we've got biodiversity and classification, your dichotomous key, all right, Carolius, Linnaeus, right, how we did to write scientific names, all of those things. And the most recent work, all of these are far more recent. You should be able to remember them far more easily than you remembered, all right, paper 1, and that is going to be the history of life on Earth. So we're just going to go through a few questions. I might skip over questions, but what I've done is to put different types of questions into each of the questions. So different types of questions on skeleton, etc., just so that right, you are familiar with different ways in which you can, all right, answer the questions. When it comes to the skeleton, all right, the first question that I've going to look at is quite as you can see, all right, it's a diagram of the skeleton. Be prepared for any of them, be able to label all the different bones of the skeleton, because remember, usually your questions are going to have a bit of a study element and then maybe an interpretive element to it. So something that you've seen and then maybe something that might not be familiar to you, but you can, all right, go back to it. It will relate to the work that you have done. If we have a look at our first question, all right, you should mind, as I said to you, as soon as you start to see pictures, your mind should be making certain jumps. Okay, the diagram below shows the main parts and it tells you of a human skeleton. Okay, so here we've got, you can see there's labels A, B, C, and D. And when we look at the skeleton, what must we remember? Not only must I be able to, all right, know the different bones, I must also be able to show the different types of joints, all right, on the skeleton. Remember, you had your synovial joints, which were your hinge, all right, your pivot, you had your ball and socket joint, all of those things. So you must be able, all right, to identify the bones as well as the joints. Okay, let us start. Question 1.1, okay, provide the biological names. Now, when we get to that, we want you to obviously, all right, for example, we don't want to hear collarbone, we want clavicle, etc. Okay, so I want the scientific, the biological name for bone C and D. All right, so number C over here, I'm going to label on the side. I was watching the program before and I noticed how the lady writes so neatly. I felt traumatized.
And she was like,
untidy
oh, no.
scroll. So I'm going to try and go slow and I'm going to go. I hope everybody, I always write that it looks like something just flew over. All right, I apologize. I'm in such a rush. I want to get through everything. Okay, the first one we identify over there. Yes, when they say biological name, you may not say the tailbone. Number C is the coccyx. And Megan knows because she's been studying anatomy this year, so we should actually be, haven't you?
I'm kidding.
Yes,
No, I have.
No, you have.
I really
You
have.
told me you have, that's
Just
why.
kidding.
And then number D, all right, that is the femur. Again, it will not be acceptable if you write the thigh bone. So you
Or
can
leg.
see there, or the leg.
That's just like
I'll
completely
tell you what,
wrong. That's
I'm
the
going to go,
bottom.
you know what, for this section, I can actually sit there and you can come. That would
should
be
come and
fabulous.
teach.
I'm sure you could. All right. Now, next question. It says carefully mark an X on the diagram. All right. So you need to go to the diagram, right, and you need to mark clearly on the diagram, all right, the position of a hinge joint. Okay. So we've got to mark two things. We've got X must be a hinge joint. And we're not finished, all right? And Y to show a ball and socket joint. So there are two parts to the question. You need to put an X and a Y, all right, on the diagram, each of them showing the different kinds of joints. Exactly what I said to you, all right? What have we combined? The bones of the skeleton, right, with the different types of joints. Now, the hinge joint always go with the most obvious. And the most obvious hinge, all right, if I turn around, it's like a door up, okay, and closed, and a ball and socket. You see, you know exactly what I'm talking about. You are so awesome. Right, wait till... Okay,
have
ball
to
and
know this.
socket, right, ball fits into socket, lots of rotation. So if we have a look here, the X is the hinge, and that I'm going to see, there's my elbow joint. So I clearly either label it like that, or I can put an X, all right, over the joint. Then I have to put a ball and socket joint, and the ball and socket joint is at my hip. So I'm either going to label it Y, or I can place a Y over my ball and socket joint. Okay, so it says to you to mark on the diagram. So there we go. I've either labeled it or I've marked it, and that is for 2 marks. Nice, easy questions here. Right, this is a section where you really can score marks. Question number 3. How many lumbar vertebrae are there? All right, one of them is indicated by label number B. Okay, lumbar vertebra, right, is over here, and it's a simple studying. There are 5. Right, there are 5 lumbar vertebrae. Nice and easy. See, get you into it easy. Last week I started off with a bit of a difficult one, I think, and all of you just sort of died of heart failure there. All right, now, question number 4. Explain how the region of the skeleton labeled A, all right, and it's the pelvis, right? Number A is our pelvis. Now, what I'm asking you here, this is the more interpretive aspect. Explain how the region of the skeleton labeled A, and we said that number A is the pelvis, is adapted in a woman, all right, for the process of childbirth. So basically what I'm asking you is, how is the woman's pelvic area slightly different to that of the male's? right? And the answer that we're looking for, right? Remember, a woman's pelvis isn't bigger, all right? All that it is, the bones are tilted outwards. So if we have the bones tilted outwards, what does it do? We have more space.
I know there's also a woman's pelvis is like obtuse, like that,
There we
and
go.
a male's pelvis is a little
Yes.
bit more acute.
All right. You see, Megan can come teach it. I can go and have coffee. There we go. I think that's a break. Then I'll come back for the next
Yeah,
section.
come back to the next
that,
break.
That sounds awesome. All right. Okay, so when what we're looking at, the pelvis, this area over here, okay, is going to be wider. There's more space. We can say tilted outwards, more space, wider. All right, and why is that? What is that? How does that assist with the process of childbirth? Because it's wider. All right, I'm going to put it in very simple terms. The baby fits better. That sounds a bit childish, all right? But what we're basically saying is because it's a wider, remember the baby's head, you haven't done reproduction maybe yet, but the baby's head needs to go down. And if that space is wider, it allows for the baby to obviously fit much better. Am I right, Megan?
So proud.
Yes, I
See?
know, I know. I'm so proud of you.
Thank you.
Okay, a different kind of question on the skeleton. If we have a look over here, bringing in joints, as I say to you, here is a typical synovial joint. Also, from the synovial joint, you must be able to label it. All right, so it says, if we have a look at the question here, it says, consult the diagram below and answer the question that follows. Give a suitable heading for the above diagram. Here we can allow a little bit of flexibility. Some of you looking at the first thing you might say looks like the knee joint. It is, you can say that, all right? There's a diagram of the knee joint, or it's a diagram showing a typical synovial joint, all right? So we'll accept. I'm going to go, okay, typical oh yeah, you see my handwriting. That lady's like handwriting comes back into it. All right. All right, label parts 2 and 4. All right, now, when we get to the synovial joints, remember, what did we have? We had a synovial capsule, and number 4 is the synovial fluid. Okay, remember, when it comes to synovial, we want the joints to be able to move freely. So because the bones, all right, if they move freely, we don't want them to rub together. All right, so that's why we have to prevent friction. So we've got fluid in the space, we've got cartilage in the space, everything that enables us, will enable the bone to move much, much easier and with the least amount of friction as possible. Okay, state the functions of parts 3 and 5. Now 3 is the synovial membrane. All right, I'm going to put the functions on here. And the synovial membrane, its function, quite simply, all right, if I have a look now, is to produce synovial fluid. All right, and synovial fluid is there, obviously, to prevent friction, which is the same function they asked you for 3 and 4 and 5. Sorry, 5, as I said to you, is cartilage. You can be specific and say hyaline cartilage, or you can say articular cartilage. All right, any of those. And again, what is its function? The same. The fluid and the cartilage, all right, are there to prevent friction. If we have a look at the next question, all right, some of you will like it because it's a question on David Beckham, right? And what it is,
Me.
me.
Like, pick me.
Pick me. All it is a comprehension, and it just tells you, if you have a look at the story, that David Beckham, when he was here, right, he had an injury. And if we have a look at these words that you'll see, metatarsal, you'll know that is
Toes.
ankle.
Whoa.
Not ankle. No, it is. It's not your ankle, it's your bones of your foot.
Yeah.
It's your bones of the arch of your foot.
There we go.
All right, and you will hear things over here that he had a tackle against the Bafana and he landed on his wrist. all right, and then it carries on, all right, about his scaphoid fractures in his wrist, which are, all right, his carpals, wrist bones. Even tell you, have a look. The scaphoid is one of the 8 carpal bones in his wrist, and it tells you all about it. And basically, all they're asking you, the answers for a comprehension, the answers are in the body of the text. It is the nicest, all right, of all questions, is when the answer is there, you must just be able to find it. Now, before you started grade 10, all of those words would have been a bit gibberish to you, but after you've studied the skeleton, right, all of those terms should have been, right, you should have been able to do it. So you'll see exactly where will you find the radius in the human skeleton? Where will you find the radius?
In the arm.
All right. In the arm, especially the forearm. All right, so there we go. Remember the hand, radius, and there it's the one by the thumb. State the difference between a ligament and a tendon. Mammalian tissue coming back to attack me. All right, already in the first paper. A tendon, what does a tendon do? I'm almost finished because I see it's time for a break there, but I'm almost finished. A tendon joins muscle to bone. And a ligament joins bone to bone. There we go. Right. So here, giving you the comprehension and then asking you, being able to just draw and tease out a few questions. It's ons reg for a break.
Reg.
Oh, so
Ready.
so quickly, I tell you. Woo.
Grade 10, put those pens down, or pencils if you must. And you know what? Just go grab some water or sit back on the couch and relax because we're going to take a break. We'll see you straight afterwards. Welcome, grade 10. So I'm here. Remember I had that little snippet in the beginning and I said I'm going to tell you about a competition. So this is my little spot to tell you about our Safeway K53 Be a Bright, okay, this is failing. Be a Bright Spark competition. Good Lord. It's like a little tongue twister there. But anyway, all you have to do is purchase this lovely book which helps you. How did it help you? A lot, right?
Listen here, I'm old.
Okay, but it helped me a lot.
My first license, I didn't ride K53, but now my next one I had
it's got
to.
pretty signs and all these things that will help you get through your learners. So please, guys, all you have to do is buy one, or you can buy one on Google Play or the Samsung Galaxy App Store. Easy. You also have to like Safeway's K53 Facebook page. We've entered all the things on our Facebook page, which is facebook.com/Learn Extra with an X. And you have to like their page and you enter the competition. You have 3 days left to win yourself a Chevy Spark L. So I would get voting because I would really like to win a car for free. So that's all I have to say about our K53. But please get talking to us on the Facebook page. I'm feeling very lonely. It would be nice to have someone talk to us a bit there.
Yeah, we're lonely. We feel unwanted. Yeah, sigh. Sigh.
So let's get back to math. I was about to say
math.
Let's get back to our life sciences and then we'll talk a little bit about it again later. Okay? Go for it, Cheryl.
There we go. All right, welcome back, guys. We're now going to go into the heart, which I think is one of the more...
That's complicated.
That's exactly what I was
about to say. It took me so long. I was like, whoa.
See, Megan's studying radiology. Hey?
Yes,
so
radiology.
She's doing all this stuff. So did you do life science at school?
Nope.
No, she didn't. So all of this is like new. And she's
I had to
working
learn
really hard,
very hard, guys. I had to draw pictures and stuff. It wasn't easy.
So when we're looking at the heart, right, the heart I've chosen, as I said, there's such a variety of questions. You really need to go, I think, on the mindset. There's lots of lots of resources that you can get. Notes from all the years where we've put questions in. Right, so I have chosen 3 different types of questions. One, just this very simple one in the heart. I know you can get more difficult ones, but I've chosen a more difficult one in the arteries, the veins, and the capillaries, and then you'll see how we can ask the lymph system. Okay. Having a look over here, as I said, it's a simple one to start off with. Sometimes, start off with the simple, ease into it, and then get a little bit more difficult. The question here is quite, as I said, quite simple. It shows the double circulatory system of humans. Now, as soon as you see double circulatory system, you know, all right, that the heart, if we have a look over here, where must it go? It must go to two places, so to speak. It must go to the lungs, which is our pulmonary, all right, and it needs to go to the rest of the body. Right, there, systemic, systematic.
Sorry.
You're an engineer.
I spelled it wrong.
Don't worry, my son had to learn Skakuza the other day and he kept on saying Suzuki. so I hope his teacher, realized.
Bless him.
So we've got to go, remember the heart to the lungs, gaseous exchange occurs, back to the heart and then to the rest of the body to get all the oxygen going and then to get the carbon dioxide. So let's have a look at the diagram. Okay, the first question, you need to think carefully. Don't just ram into the questions first. The first question says, which circuit starts at the? Now, I have given you the two different circuits. All right, so one, we know pulmonary to the lungs, and the systemic, as we said, goes to the body. So, which of these starts at the left ventricle? Now, remember, guys, okay, when you do left and right, you must cross over. So, if I'm looking at this over here, this is my right side, that is my left side. Okay, so it starts at the left ventricle. So my left ventricle is here. Okay, and it ends at the right atrium, which means it must go out of the left ventricle, right? Where does it then go to? The left ventricle goes to the aorta, and the aorta goes to the rest of the body. Okay, and then where does it come back? Comes back to the right atrium. So my first circuit is my systemic. Okay, my second one, all right, starts at the right ventricle. So I start over here, and then I go and I end up at the left atrium. So from my right ventricle, I go to my right atrium. My right atrium, I go out to the heart, all right, via the pulmonary arteries. Where do I go to? My right hand side goes to the lungs. Okay, so my left hand side goes to my body, that's my systemic. My right hand side goes to my lungs, which means that my right hand side is then going to be, all right, my pulmonary. And that's going to the left side. Okay, now the question, next one, write down the name and number. Please be specific. There is an and, okay, the name and the number. The mark allocation, 2 marks. If you write one or the other, you're only getting half, and that is such a waste. Okay, the blood vessel which carries deoxygenated blood away from the heart. Now, if we go away, A for away is always arteries. You make my heart so proud.
Oh,
You're doing so well.
Thank you.
Last year this time you were so clueless.
I was so like, what
yeah,
is this?
Yeah, no, I really am. I must admit. Hats off to you. All right, so now an artery, A for away. Now let's have a look. Something that goes away from the heart. Okay, an artery that is going away from the heart, and it must be carrying deoxygenated blood. Which side is deoxygenated blood? The right-hand side. What's coming from the right-hand side? The exception to the artery rule, because where is it going? It's going away from the heart. It's going to the lungs. It is my pulmonary artery. Okay, A for away. All things going away are arteries. Now, the blood vessel. Now you see, I only did half. What number is it? It is number 1. So, 1 pulmonary artery. You see, I almost forgot to do naughty me, and I said careless. Okay, blood vessel which returns oxygenated blood to the heart. Okay, now what side? My left side receives oxygenated blood to the left side of the heart. Where has it come from? It's come from the lungs, so it's also my pulmonary, but all things leading to the heart are the vein, and what number is coming back? It's going to be this one. It's going to be my number 4. There we go. I did pink all over it. Okay. All right. Nice and easy question. Okay. Next question, a slightly bit more challenging. The information below compares. So it's a comparison, if you have a look here, between my different blood vessels. My artery, my capillary, and my vein. All the information is here in front of me. I have everything. It's a data response question, all right? All you now have to do is to be able to sift out that information and see which part is going to be necessary. Okay, so let's have a look at the questions first, and then we go to the diagram to see, right, what is necessary. Question number 1 says, describe the structure of a capillary. All right, and now it says, using information from the graph. They don't want you to say, oh, it's this, 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 and this. Probably those points are going to come out. But it must be points that the information that we've given you. As I said, nice and easy, the information is there. Okay, so let's see, what does our diagram tell us? Okay, we start off over here. First thing that it tells us, all right, if we have a look here, mean diameter. All right, you see 8. And as soon as you say 8, you think, oh, yeah. But what do you not notice? That little unit. These are 4 and 5 millimeters. That is 8 microns. All right? And there are 1,000 microns in 1 millimeter. Okay, 1,000 microns in 1 millimeter. So it's telling you it's tiny, tiny, tiny. Okay, so describe the structure. The first thing we know, right, it is very small. It tells us, look at the diameter. Look at how thick the wall is. The wall is very, very, all right, so we know it's small, right, it is very thin. Okay, because that's what it says here. Look here. Thickness of wall, it's not very thick, it's thin. Diameter of vessel, very, very small. Okay. Also have a look here. Relative thickness shown by the length of the bar. Right here, relative thickness. Do you notice it only has 1? Read the graph. How many layers does it have? And it's only 1 layer, which links in with the thin, right? 1 layer thick. There we go. Describe the structure. Very small, thin, 1 layer thick. All right. It's telling you, you could even put 1 layer of endothelium. All the information on my diagram, given it to me. Diagrams and little blurbs, little passages are fountain of information. Don't just breathe over your diagram. Don't just breeze over little comprehensions. Those are marks for jam, really. Okay. Question number 2. Explain how the structure of the capillary is suited to its function. All right. Now, all of these things. We said it's very small, and technically it's very thin. Right. So what is it? How does it help? What is the function of the capillary? All right, the capillary is there to, let's have a look, draw. There's my capillary, there's my cell. Okay, so what does it do? It brings in oxygen. It takes out carbon dioxide. So it helps with gaseous exchange. The thinner it is, the easier all of this can occur. All right, so it makes for easy transport or exchange if you want to use. See, now I'm telling you, now I'm writing all funny again. Now I'm thinking, oh, I must write nicely. All right, so there we go. One of the things. What else do I have to get in? I need to get in food. And what else needs to go out? Waste. All right, so as you can see, the capillary is the whole exchange mechanism. All right, for gases and for nutrients. Okay, so the thinner it is, the easier all of that is. Also, the thinner it is, right, what about my blood cells? If it's nice and thin, my red blood cells have to fit through in single file. All right, and if they have to squeeze and fit through in single file, it's much easier for oxygen to go and carbon dioxide to come in. Instead of all this mass, all right, it enables, once again, our exchange of our gases and our nutrients. Am I right, Megan?
You're right.
Because you're actually shaking your head. I can just see the light has gone on. It's amazing. Okay. Now the next question has got to do with the artery and the vein. Okay? It says here, explain the difference. Doesn't say tabulate, right? It actually asks you to explain the difference between the thickness. So let's look at the thickness if we have a look over here. All right, there we go. The thickness of the walls between the artery and the vein. Okay, it says explain the difference between the thickness of the artery and the vein. So why an artery, all right, has thicker walls. Now let's be particular. Let's have a look over here. Which walls? Let's have a look. Look at this. That is the most, right, that is the most telling. The artery has thicker walls, especially the muscles. Why? What do arteries have to do? Arteries have to pump blood. All right, to all parts. And the more muscle you have, the harder you can pump. The harder you can pump, the more blood you can, all right, send out. So much better. Under high pressure is your artery. Okay, so there we go. All right, not even a single diagram of an artery or vein, just a table telling us the different thickness. Here, the layers are even given, all right, and from that you are able, from your knowledge, right, to be able to give me the difference. This diagram over here is diagram of lymphatic system, all right, and the reason why we know it is a lymphatic system is because this little point over here. Why do I know that? Let's answer the first question. Okay, that is my giveaway. I'm going to, there we go, my pink. All right, my pink. How do I know that that is the lymphatic system? Okay. It says here, the flow diagram illustrates both circulatory system. One is the circulatory, all right. If you notice, I'm going to change color. Let's go to green. There we go. All right. There we go. That is going to be my circulatory system. Let me do that so you know. And let me go back to pink, because that is my lymphatic system. Provide two differences between the systems of the body, all right? I'm going to just tabulate because it's easier, and to just get into one we know is my lymphatic, and the other one is my circulatory. Right, and if we have a look at my lymphatic, why do I know it's lymphatic? What did I start off with over here? All right. The lymphatic system is not a closed circulatory. Right, remember, closed circulatory, start, finish, start, joins up again. All right, what happens here? My lymphatic blind ending vessels just start. It's not a closed, where my circulatory system is a closed. Have a look at the green. Right, I go from a blood vessel, a vein or an artery, let's say artery, to a capillary, to a vein. So the fluid is always contained, right, within that system. Where's my lymphatic system, right? What happens is all the fluid that moves out from the blood plasma, it will then filter into my lymphatic system because it's an open-ended system. Okay, all right, what else can we, another thing, all right, what does the lymphatic system carry? Lymph. Oh, my mother's heart.
Just
okay,
like
and a circulatory system?
blood.
Blood. and they are different. All right. Provide a name for fluid A. Fluid A is the fluid around the tissues. All right. So inter means between. Okay. And stitial means cells, or, nice and easy one, I suppose, intercellular. Between the cells. Isn't that what it is? Let me make it another color. Yellow, my least favorite color. All right. There we go. What those round things are cells. So it's fluid in between the cells. All right. Provide a function for the lymph nodes. The lymphatic system, all right, the lymph nodes itself, those of you who've ever been sick.
Yeah, if you, they usually
what is
feel
it?
here.
All right. What do? They produce white blood cells called lymphocytes. And lymphocytes might help you fight disease. So I'm going to put here your immune system. It's time for a break, isn't it?
I'm just looking at you like.
I
I'm
just
kidding.
wanted to finish that question. I don't want to go mid-sentence.
Finish it.
There we go. Break.
Oh, you finished?
Yes.
Oh,
yeah,
goodness.
that's what I said. You said break.
Sorry.
Thank you, James, but yeah.
Thank you so much. Well, guys, just have a little bit of a break, and we'll see you straight afterwards. Welcome back, grade 10s. We're here for life sciences, not maths. And we're here to do and carry on with some questions. We have sadly moved away from anatomy, and I have no idea what we're doing anymore. It's again animals, and I don't know. So I'm just going to leave it up to you and Cheryl. You tackle those questions. How about that?
Yeah, no comment from the
Yeah, just
sidelines,
zip.
Megan. You can see she looked at the board. She goes, don't know that. Won't be answering anything anymore. All right. Okay, guys, we're getting to our last section of work. All right. Our environmental, with our biodiversity and classification, also with our history of life on Earth. There's such a variety of questions that we can ask here. I'm going to go on to the food chain one, but don't forget your biomes. All right, when we do biodiversity, I'm not going to go into depth. I think when I did the biomes, I did give you a question like this. So go back to the notes that we looked at. B, you need to know the different biomes. You need to know, why is biodiversity so important? Biodiversity, this is, all right, biodiversity, the different variety. Be aware of the different endemic, all right, and indigenous plants that make our country so unique. So if you have a look there, all we just basically asked you can you recognize certain, all right, traits? The next question, right, already, you should, I guess I said, trigger the mind, is a question related to food chains. And you can ask so many, all right, questions on the environment just by showing you a simple diagram of the food chain, because a whole lot of the environmental concepts are going to come into play here. So let's go through, all right, a question. It says below, the diagram below shows the feeding relationships, all right, and we know that is going to be a food web, all right, because it is a whole lot of food chains that are linked together, and a whole lot of food chains linked together makes up a food web. But here, all right, is a coral reef. Now, for those of you, all right, coral reef is underneath the water. Right, we very often, when we get to these, we tend to stick to the terrestrial because it is the more familiar. But now we're going to have a look, all right, at the word I'm looking for, aquatic. All right, let's look at the questions and see from the diagram. It says, use the diagram to explain, I want to know why, a coral reef can be described as an ecosystem. What is the definition of an ecosystem? An ecosystem, all right, is an area or a large area where, what do we have? Interaction between. And here's our two words. abiotic and my biotic factors. That's the definition, as it says. Now it says, use the diagram to explain why a coral reef is described as an ecosystem. Here we have the very top corner. It says there, these are the biotic components, and these are the abiotic components that play a role. All right? So it tells us, the diagram itself says to us, okay, what is an ecosystem? It's a place where there's an interaction between my abiotic, my non-living, and I'm going to, oh, here we go, the handwriting again. Let me draw a line. There we go. My non-living, and how it interacts with my biotic, which is my living. And there we go. The diagram itself, right, shows you with the use of the arrows the interaction that is going to occur between them. The abiotic factors are going to determine what biotic factors are going to be present. All right. Now we need terminology here. Explain why the sea stars are both a secondary and a tertiary consumer. Remember, a consumer eats. They cannot make their own food, therefore they need to eat. So if we were to put our triangle, our trophic level, remember, what do we have? Producers first, then primary consumers, then secondary consumers, then tertiary consumers, and then quaternary, up to depending how long your food chain is. Okay, so we want to know, if we have a look at the sea stars, and where are, I think, have a look over here. Okay, why are they a secondary? They are a secondary in which food chain? Because they get eaten, all right, not eaten, they provide food, they eat, should I say, sponges. So let's have a look. Phytoplankton, all right, that is going to be my plants. It says there, autotrophs. There's my plants. That's my producers. Sponges are my primary consumer, which makes my sea star, all right, a secondary consumer. So in one food chain, all right, it is the secondary consumer. But let's have a look at another food chain. Let's have a look at this one over here. Phytoplankton, there's my producer. Gets eaten by the zooplankton, which is my primary consumer, which get eaten by sea urchins, which is my secondary consumer, which then gets eaten by my sea stars, which is my tertiary consumer. All right, so if we have a look over there, why is it both? All right, in different food chains, it has a different. You're so quiet now, Megan.
I know, I'm like,
Hey?
what?
Oh, I can see that. I can
just
hear you like going, oh, go back
don't even
to
know
the
what this is.
anatomy. Yeah. All right. Name another. Now you must read this carefully. Abiotic factor, non-living, besides. So you cannot use the ones that we have listed. Now, when you do this, all right, you need to be very careful. We are in the ocean, all right? We are in the ocean. Soil might not be such a great answer. Soil is going to play far more, right, of a difference on land. So be very careful if you use soil as an example. If you have a look here, thinking back, think of physiography, aspect, slope. No, that's not going to work. What is the one thing that we are missing over here? One of the abiotic things, and it would have a huge influence, all right, is going to be, can you think of what it's going to be, Megan? Oh, you see,
don't choke.
Baby choke.
She's like, oh,
What's
no.
it? Starts with a T.
T, E,
Oh, you know.
what?
Temperature. Is my
Oh.
writing so bad?
Oh, wow.
All right.
So
Temperature. Okay. Whether the ocean is hot or cold, that has an effect on the organisms living there.
Mm.
Oh, now I'm sad again.
Yeah, I'm
Now I'm
sorry.
sad again. You let me down. Let me down.
So
All right.
sorry.
Now we have to. We're going back from here. We've done what we can with reading. Now we need to think a little bit. All right. One of the question here. State two ways.
Ways.
2 ways. Only 2 in which human activities, all right, may affect the coral reef ecosystems either directly or indirectly. Okay. So if we have a look at coral reefs, beautiful areas, all right, lots of fish. So if we have a look, how may we affect it? All right. What do you think we can do? Any thoughts, Megan? We're giving you a second chance here. Are you going to come up with
that's so
it?
sweet.
Yeah.
Well, the only thing I think of is when you dive, you know,
Oh.
and then you touch the coral because you want to touch
Ah,
the fish.
there we
swim with
go.
the fish.
What happens if you're diving and you're not supposed to touch or
No,
pull
you're
off?
just supposed to look.
You're
and keep
supposed
your
to
hand
look
on
when you
it.
go diving, right? A little bit of general knowledge also know here. What happens if you go diving? You mustn't touch anything. It's a general rule in nature. Don't pick anything, all right, unless it's in your own garden. Just leave everything there. If you pick it up, what you're going to do, you're going to damage it. All right. What else?
Indirect. Is that's
Yeah,
directly,
what else
right?
what about fishing?
Fishing, yeah.
What about tourist? It's a lovely tourist attraction.
Mm.
All right. So in one way, we can actually damage it, but on the other way, all right, it can bring in tourist attraction. So here, which also leads to the next one, explain how conservation of the coral reefs may benefit the locals. What do tourists bring in?
Money.
They bring in money.
Cash moolah.
Definitely. All right. And if you have lots of jobs, there we go. What do those people again get? Money.
Lots of money.
All right. So you're providing jobs, right? You are also, all right, developing the community, etc. Those kind of things. Okay. All right. And then one question that is quite common in the food chain. It says the parrotfish, which is in the diagram, became infested with a virus, during which drastically reduced their numbers. Explain 2 effects that this might have. It's a common question here. If I take out this, all right, now you need to explain. The parrotfish, right, eats quite a few. It eats the octopus, right? So what happens here? If the parrotfish disappears, okay, what happens to the octopus? All right, the octopus doesn't have enough food. So what can happen to my octopus numbers? They might go down. All right. Or what will happen to my coral polyps? They don't get eaten anymore because the parrotfish are gone. So their numbers will increase. Okay. The lots of the things you can, all right, take from the side there. I see my nose is itchy.
It's okay, scratch it.
Always
Enjoy
like
it.
this. I always get the sneezes. This and in church. All right. Okay. So when it comes to these questions, right, nice to read.
James wanted to add his input. He said they also bring skills, tourists.
Oh, James, you can come down here.
Yeah,
See, thank
come.
you. Skills to tourists. Thank you, James. James is the one who whispers in our ears. No.
Yeah.
All right, next question. Now remember, I can put in a dichotomous key. Remember, scientific names always underlined. We go to the history of life on Earth. Here, if you have a look, is a question on the fossils. All right, I'm going to just quickly show you. I'm going to come back to it. Oh, going the wrong way. Okay, so one of the questions, right, is the question on a fossil. 2 of the fossils that you should be familiar with are the Archaeopteryx, right? The index fossil between reptiles and birds, and the other one should have been the living fossil, the coelacanth. Those are 2 fossils, right, that in your studies you should have become quite familiar with. But let's have a look here at the question. It's asked you, shows the fossil remains of a bird, all right, and from that we can obviously ask you questions on fossils. What are these parts made up of? And you could say hard parts, obviously bone, all right, and why we know fossils, you need a hard part to fossilize, all right, soft parts don't fossilize very nicely. Okay, it asks you explain why these parts are being preserved and what is it, how fossils preserved. It was covered, there wasn't any decomposition, all right, because there wasn't any bacteria, etc. Anaerobic respiration occurred, and because of that, the infiltration of the salts, they remained, etc. So just going back over how your fossils, all right, how can you tell this is a fossil of a bird? Looking at your diagram, right, you would have been familiar that it had wings, etc. Okay, so when it comes to that, all right, or I can give you a diagram showing the extinction, and I think we finished. Oh, we're
Yeah,
not.
like now.
No, okay.
Sorry, my love.
Yes. Good luck for your exams, grade 10. All the best, eh?
Awesome. Okay, guys, I just want to quickly wrap it up. Thank you, MTN, for proudly sponsoring this with the SA Foundation, and it's endorsed by the Department of Basic Education. So thank you very much. Thank you, grade 10s, for being here. It's been awesome being with you. Been awesome being with Cheryl.
Oh, gonna miss you.
Gonna miss
Next
you.
year. Yeah.
But have a great exam time and have a great evening. See you soon. Bye.